Uh, a very good afternoon, everyone, and welcome back to today's afternoon session. Am I audible?
Yes, you're audible, sir.
Okay, so this would be a practical session. For the participants who did not join the morning session, it was taken by Mr. Rushendra Sidibomma, and he will continue the hands-on session of LLMs as well. So I request you to please take over and begin the session.
Yeah, thanks, Suren. Yeah, so I'll share my screen. So we can just try to. So there are some really important things that we couldn't fit it into the first session. So these are probably arguably the two most important concepts that we'll be running. So we'll try to allocate half this time, or less than half. We'll try to wrap this up, and then move on to something slightly more practical, right? So yeah. Suren, do we want to wait for it, or can I start? Do we wait for some more people?
I think we can wait for at least 3 more minutes and then we
Sure.
could begin.
Works. Yeah. All right.
I guess we can start right about now.
Okay.
Okay.
So yeah, welcome all back. Welcome back. So now we can start with. We are remaining with two more topics in this presentation. So I would say that they are arguably one of the most important ones, and probably the ones that you might have been working with. Some of you might be working with them, and some of you might have seen these terms come across very frequently, either in research papers or in general, with a lot of hype around them. So the first one is retrieval augmented generation. Yeah. So we'll get started. So this one, since it's so important, I have written it in a very so I prepared the slides so that we can interact well. So I think again, like for the ones who have missed the morning session, please try to be super interactive on the chat box. My chat window is still open on the other screen, so I can always see all the chats that are coming in. So if you have a question, just ask. Feel free to interrupt me. So yeah, so I'll try to explain this in a very intuitive way and ensure that it's as analogous to your daily life things as it possible. Okay. Yeah. So uh, so RAG stands for retrieval augmented generation, right? So what from this slide, so for example, it consists of two steps, that is retrieval and augmented generation. So someone from the chat can make intuition of what it could be. So we can just start, put something in the chat. Extracting from existing. Okay. Okay. So you can try to stitch these two terms together, that one is retrieval and then augmented generation. think of it in the perspective of an LLM and what we could potentially retrieve and what we'll generate. So yeah, feel free to put on your thoughts. It doesn't have to be right. I mean, there's a lot of right answers for this too. Too. So yeah, you can always yeah put down your thoughts on the chat box. I'll be waiting because this is an interesting topic. So I'll be happy to see some answers from you guys. Okay, not too many, I guess. Yeah, all right. So so the word from as a basic pipeline, right? Instead of get first diving deep into the details, we can think of so we can break these down again. These two other steps for RAG, right? So first one is retrieval. This means ideally, what would you retrieve? Correct. Uh, just give me a moment, though. Yeah, sorry about the disturbance. There was a slight fluctuation in the power. Yeah. Yeah. So we can understand two parts, that is retrieval and augmented generation. So someone again put it in chat that using stored data as context when generating a response. Yeah, that's a really good answer. That's a very good way to put at it in layman terms. So yeah, first one is retrieval. So to give more context, RAG is used when you want to give LLM something more, right? Something more powerful or something, right? So what we want to do is retrieval. Retrieval is when a user asks a query, you want to bring out the most relevant parts of it, right? That is what you would retrieve to give more context to an LLM. And then augmented generation is again a simple component which where you want to have an LLM generate the answers, the corresponding answer. Now, so the reason this pipeline is so successful is because, like we said, LLMs cannot have uh, an infinite context window, right? LLMs have a limited context window. So, for example, again, for those of you who were there in the morning session, probably you can remember that instruction manual that we had, right? So, for the ones who didn't have, I can just very quickly describe the problem statement. Yeah. Okay. Yeah. So when you're buying a car or a bike, so you do get those huge manuals, right? A lot of manuals, which is pretty big. One would ideally go through all of them, right? So now what we want to achieve is have a question and answering sort of system, right? So for example, assume that it's a 200 page 200 page book, okay, which has different questions about the workings of the car, the electronic systems inside it, and basically, for example, getting the power window up and down, opening the gas tank, and all these things. Now we want to build a sort of question and answering question and answer bot, questions and a bot that could potentially answer any question that the user has about the car, right? um, so we had discussed about fine tuning as a potential option. We discussed about a question and answer sort of supervised fine tuning instead of on a corpus. Now this is a much very better way to put it. So instead of giving all 200 pages, now again, even for it to answer, either you would have to fine tune it or give all 200 pages of the manual as context to the language model. But in this case, you don't have to, right? We'll see how to design this thing and how the architecture for RAG is set up in the next slides. Yeah. So first of all, why do we need RAG? So consider the following task: asking an LM about the procedure for applying leave in your college, who won yesterday's IPL, and whether it rained yesterday. So what do you think the answers will be in this case? Please try to be as interactive as possible for this. This would be, I'm pretty sure it will be an interesting topic to go for.
Uh, just letting you know that participants can all unmute themselves and speak for a moment if they want to.
Yeah, thanks, Sudhanya. Yeah, that'll be great. Okay. All right. So you know what? I'll try to, you know, let's see. I'll try to do something else. I'll try to ask ChatGPT so that instead of you having to answer that, I'll try to. So I'll ask this ChatGPT. At least, what do you guys think we can expect? But what can we expect if we ask this? What is the procedure? Yeah. So let's see what happens. Yeah. So what did you guys get? This is so this, since ChatGPT now has access to internet, it was able to do that, correct? So assuming that, okay, I mean, actually this is also still a good way to look at it. So if I ask this, under normal circumstances, it would have said that it would have either hallucinated something, or it would have given a common answer like you should reach out to your professor first and then the dean of academics or something like that, right? But what this exactly did right now, here is a classic example of RAG. Okay, so here it said you can download the leave application form, do so and so, submit for approval and so on. Now you can also see the citations here. They said that IIITDM Jabalpur's download page, there is some hostel leave request form, and so on. So how do you think it got to here? Do you think when I asked this question, my first question is that when I asked this query, did it go through all of the internet to do that? Or do you think it was fine-tuned on IIITDM Jabalpur's website also? Exactly. Someone answered, said Swapnil. Exactly. So it took help from an external source. Um, Actually, that's one way to look at it. But more importantly, it took help from the IIITDM Jabalpur website. Correct? Yeah, it only went to IIITDM webpage. Correct. So first of all, so now two questions arrive. It has been trained on all of the internet. You can assume how vast that would be. But how do you think it came up with it came up that I have to go to this website only? What do you think it did before? As soon as I hit the query, what happened? What was the first thing that would have happened? Did it try to look for IIITDM Jabalpur across all of the internet, or did it try to what could it have done? Domain name search of the website. Yeah, so these are things that could have happened, since ChatGPT right now is so well integrated with internet and searching across internet, various tools, all of these things. But if you were to ask this to a very normal LLM which does not have access to the internet, right, not as sophisticated as ChatGPT, then what would have happened is either it would have hallucinated or given you a wrong answer or a generic answer about you reaching out to your academics or all these things. So that is exactly what we want to solve here. Now the next question, we'll look at the next question. Who won yesterday's IPL? Fine, right? Uh, Unfortunately, the reason this wouldn't work is because if I write here, it'll try to search for the web. It'll try to search the web and give me an answer. But let me see if I can go to an alternate model. Okay. Okay. Looks like, I think, let me ask. Yeah, so you can see that immediately it started searching the web. So I did stop the process before it went through because again, we don't want our LLM to have access to the internet, right? This is the reason all of this is so sophisticated right now is because they allowed the GPT to connect to the internet. But if you ask an LLM who won yesterday's IPL match, do you think it will have an answer in general? And if not, why? I mean, now it's clear that we don't have an answer, but it won't have an answer. But why do you think so? Can someone answer in the chat box or speak up? Speaking up is also totally fine. That will be better actually, because it's not trained for updated data. Exactly. Yeah, I think that's pretty straightforward. But so to really to tell you what the exact implication is, what did it train yesterday? Again, it'll have to have updated information, right? Nope. Someone again said because it was trained for it, it wasn't the existing information. Exactly. Very precisely, that's the answer. So now, um, okay, let me see if we can have a better demonstration of that. So what uh, if we can? Yeah. So yeah, is it the better data? So if you want to check until which date it was trained for. So now if I ask who won the United States elections in 2024, you'll still have an answer. So we can check that by saying what is your cutoff date. So cutoff date is the date until which the model has been trained for. Okay. So we can see that as of now, my training data includes June 2024. However, I have real-time browsing capabilities. So you can see that this is not something we want to do right now because we want to check LLM for as is. We don't want the sophisticated mechanism of ChatGPT, right? So the data on which it has been trained on has been up till June of 2024. So if I ask it who won the elections in 2024 December, it will not have an answer, correct? So that we could as that is possibly one of the very big limitations that an LLM has. So it's a web scraping. So basically, it's web scraping too. Yeah, very precisely, Swapnil. So that is what OpenAI has integrated into it. So not just web scraping, but it has access to internet. It can scrape data and it can um, collect information from different places on the internet. That is what OpenAI has integrated. That's why it's such a powerful tool right now. Correct. You can even give it tools like writing code. It can write, if I'm not wrong, it can write code to some specific places on your system too, right? You can have deep research, which will ideally be doing some research when you're like trying to look at a topic, create an image, and all these things. Think for longer where you wanted to reason. So all these capabilities are built into an LLM, but the base LLM or the vanilla LLM that we're considering right now does not have all these capabilities. There are things that have been integrated into it, and we'll discuss how they have been integrated too, definitely. But yeah, so for now we concluded that the information that it has been trained on is only until June of 2024. Now, as precisely someone on the chat box said, we want it to be able to keep up with the updated information, correct? And that does not mean that we can train a model every day, right? It's not practical to say that, okay, every day I'll train the model until the day, things that happened yesterday. First of all, it'll take way too much, it's a lot of wasted computation. And on top of that, uh, it might still miss out on a few things, correct? And the more importantly, the context always matters, correct? So things that have been trained together a lot before may have lesser importance than the ones that we have right now. So that's why the answers for those questions, first of all, is LMs have a fixed memory. Once trained, they don't know anything what happened after the training cutoff. That's what we just looked at. That is 24 June of 24, which means that they can hallucinate when asked about something that happened after the cutoff date. So if I were to ask an LLM that did not have internet connectivity, that what who won the elections in 2024, it might have either told that it doesn't know about it or given a wrong answer. Then again, for the part where the example in which you want to know the procedure for applying leave in your college/office, sometimes right now, like we saw Jabalpur, it had it on its website, right? But there are also some private organizations who don't have this data publicly available, correct? So for example, some office, I don't know, for example, Google's policy for uh, applying for leaves, they obviously won't have it publicly available. It's private data. It may be present in the handbook that you receive, that the employees receive on their onboarding. So this is something that we want to solve, right? We want to be able to have a question and answer system, or even be able to interact with such documents. And that is where RAG comes in. So how does it work? Firstly, a RAG combines retrieval, that is fetching relevant documents, with generation, LLM generating responses based on those documents. So ultimately, what here we've broken down the process into two simpler steps, which are easy to achieve. So instead of training the LLM on who knows what, how much data on this on the internet, what we try to do is first given a query. So first of all, I'll ask a question about the process for applying leaves or so on. Now it will try to search it in a knowledge base. Now you, for example, for the sake of to ensure that we're on the same page, we'll only consider one example going forward. That is, for example, the process of applying for leave at a private organization whose documents are not public. So when you join that organization, you will receive a handbook again, right? One will have about policy for leaves, the policy for how many leaves you can take it, potentially the working hours and all these things. Each of them will be in a different PDF, correct? So the first thing, the moment I ask a question, how do I apply, or even simpler, how many paid leaves do I get? So what it will do is it'll try to first search in that knowledge base. So knowledge base here ultimately becomes the ground truth, right? So knowledge base is what. So instead of for an LLM, all the data that has been trained on, that becomes the environment for it. So instead of making that an environment, we are trying to make sure that everything it answers must be out of these set of 10 documents only. So we're trying to change this process called grounding. So we want to ground the LLM to believe that this is the only information that is accessible to it, right? So now it will try to search the document which will have information about paid leaves, correct? So there's probably a document about leaves, a document about how to apply for a leave and all these things. So it will try to pick out, it will retrieve the document which has information about how many leaves a person gets, an employee gets. So that is the first part of our pipeline, that is retrieving it. Then once you retrieve it, you pass the retrieved content plus the original query to the LLM to answer accurately, right? So um, yeah, actually, we can have an interesting question on this. Let's see. So let's talk about today's uh, presentation, right? So it doesn't have any information about it. Let's say first, for example, at the end of this presentation, okay, the coordinators or everyone created a report of this presentation. So I'll say report of a presentation that happened on May 31st, 2025. Number of participants 100. uh, Names of participants, there'll be many X, Y, Z. Okay, and potentially a topic too, right? So this was the report. Obviously this will be much longer, right? This could be pages, this could be minutes of the meeting, probably tens of 20 documents, for example, if there are 20 speakers overall, right? So now assume the coordinators gave this created a report out of this. Now what we want to do is make sure that the LLM knows this, right? So assuming that this was a 20-page document, okay, and this was for today's topic, and then there'll be 20 other such reports. What we want to be able to do is, now if I ask a question, who who spoke on 31st May, it'll not have an answer, right? Just as a quick question, I don't know what it'll say, but I mean, it's again searching for the web, which is something that we don't want to do. So who spoke on the 31st May, it doesn't have an answer inherently. But now if I say this is the context, now what I will do is, the moment I have this question, who spoke on 31st May, I will take this query and find the similarity against the 20 documents that the coordinator created potentially for corresponding to each speaker. Now we will return the closest matches, the three closest matches, top three or top two closest matches, and out of those top two closest matches, we'll have this, because May 31st is a common word, and based on other potentially strategies or something, we found out this is a similar chunk. Now we pass this as context, so we'll say context is this. Now query is who spoke on 31st May. So this, you can see that this is the exact same question that I asked before, right? So now if we give it, Rushendra spoke on 31st May, correct? So what we ultimately did was very precisely the traditional RAG approach, right? Someone asked on the chat, is it similar to knowledge distillation? No, absolutely not. So knowledge distillation is a completely different topic, right? We can discuss that towards the end if we get some more time. But yeah, so this is knowledge distillation is something else. We'll try to discuss that towards the end. So here, ultimately, what we're doing is we're trying to ground the LLM and give it the required context only. If I were to give it 20 pages, it still could have gotten it wrong. I mean, in ideal situations, it wouldn't have. But if these were like 20 huge documents, or it could have even had the minutes of every single meeting, it will become way too huge, right? So what we're doing here is giving the LLM context of only the relevant parts, right? Does that make sense? So I mean, just to make sure that everyone's following, could just put a yes if on chat, if you can kind of follow what's happening here. We'll go through each step furthermore, because it's a really important thing. And yeah, I'll be waiting for a couple more yeses. Okay, yeah, yeah, sounds good. Okay, so we'll go back to the presentation. Yeah, so like I said, it's a retrieve and generate process, and the analogy is like a student looking up class notes or textbook before answering a tough exam question, right? Assume that this is, I think, a really good example too, where, for example, it's an open textbook examination. So you won't try to, yeah, actually, I think this is a very perfect example. So you won't try to remember every single answer, right? You won't try to remember every single topic. You see the exam paper, you see that it's a question about, I don't know, for example, a C programming. You'll only look at the chapter that talks about C programming and try to find your answer there. You'll not try to remember all the book. You'll not try to find the answers in all the entire book. So this is exactly what we're doing, right? So this is a basic diagram or flow chart of what happens in a rank system. Okay, so first we have data indexing. uh, okay, like we talked in the morning. So first thing, uh, can so right now I have 20 documents. How do I put it in a way that an LLM understands? Can you tell me? At least the ones who were there in the morning session should have a fair estimate of an answer. First of all, does the LLM understand these documents? And if not, in which form do we have to create them? Yeah, correct. So embeddings, right? We need embeddings of the documents. So first thing, what we want to do is we have 20 documents. Yeah, vector representation, like correctly said. So we have, for now, let's take that example again. So we have 20 documents, right? We want to break it down into chunks, small chunks. This process is called chunking. Right now, since I'm saying that each of these document contains the minutes of the meeting and the details about one speaker or one what happened in one presentation or session. We can less reasonably assume that chunking it such a way that one presentation or one speaker for one document is a good enough strategy, right? So now we have 20 chunks, each chunk representing the report for that particular presentation, correct? So we want to do that, and then for each chunk we want to create an embedding, right? What is an embedding? Embedding is a vector representation of that chunk of text. So we want to create a uh, embedding of that chunk and put it in the vector database. Okay. Why do we call it a vector database instead of a database? Because we're only storing vectors, correct? Because ultimately, each any input string you give, the ultimate output from the chunk, embedding process is a vector of predetermined size, correct? So now we'll store the chunks corresponding to each of those 20 documents or 20 the embeddings corresponding to each of those 20 chunks inside this vector db. So now ultimately, after indexing, that is called data indexing, first we're forming the knowledge base for the LLM. So we'll do the data indexing. That's this process. So now ultimately, after data indexing, we have 20 chunks in our vector database. Does everyone agree? Probably a few yeses in the chat would help. Yeah. Okay. Cool. Got it. Nice. So now we have 20 chunks in the database corresponding to 20 embeddings corresponding to each chunk. Now the user asks a query, who spoke on 31st May? That is a user's query. As simple as that. Can anyone guess what will happen next? I think we talked a little about similarities and all. Can anyone guess what happens after we get the user's query? You can even unmute if the answer is too long to type. Just reminding you again. It will search in the database. Someone said it will search in the database. Yes, but uh, what? Maybe an error? I mean, okay. That definitely not happening. So yeah. So first thing is the user's query. First of all, what is it going to be? It's going to be plain English text, right? And again, how will you compare plain English text with vectors? What's the first thing that will happen to the user's query?
The user query will be embedded into like a vector, and then we will search the similar vector in the vector database.
Yeah, perfect. That's the exact answer that we want to that we were expecting, right? Yeah. So yeah, precisely the user's query, like I said, who spoke on 31st May, will calculate an embedding corresponding to that. There'll be an embedding that is assume that's the blue block here. Now we know that cosine similarities. There are multiple retrieving techniques or multiple similarity math measures that can be used. For the sake of simplicity, right now we can assume the cosine similarity. So this embedding. Now this is a vector, right? You will compare this vector with every single of those 20 other vectors in the database. You will compare a score. So with vector 1, there is a score of 0.3. All of them will be 0 to 1, right? So 1 will be 0.1, 2, 3, or 0.37. And then finally, potentially, if we have a good schema, if we have a good similarity score, right? The ones, for example, the report for today's lecture will have the highest similarity score, that is 0.97 or 0.98, right? Something relatively higher, much higher than the other ones. But by default, we can't always say that the first one will be the most relevant only. We can't guarantee that, right? Because similarity score is just a heuristic. There could potentially be cases where a not so similar chunk would have matched first, but the second chunk has the most information. So it is a convention to choose the top k chunks, right? Top k, for example, you have 20, assuming k is a hyperparameter. You set it based on your architecture, your system, how close you want the answers to be, or how accurate you don't, right? Or how you might want to risk it, right? For example, if you keep top one, the answer quality or the efficiency might be slightly better, but you might not always be guaranteed a correct answer. So I would say right now we can say top three. So the top three chunks which have the highest similarity scores, that is my block, that is 0.97, 0.8, and 0.7. These three are the top most similar scores. We'll pick those chunks. That is each of those pink blocks. Now we will give an LM saying this is the context you have. Or you could obviously could play a lot with prompting, or you can say this is the relevant information to you. Do not assume anything outside these three blocks. Okay. You just straight up put it in the prompt. You do not use any external knowledge, anything outside these three chunk of blocks, right? And then chunks of text. So you don't consider anything outside that. Now based on this, answer the user's query, correct? So, and it'll generate a spit out an answer which will be the most relevant. This is how a RAG system is designed. This is how the flow of a vanilla RAG happens, right? So yeah, so any doubts over here? I think I can see a question. So if I take image as an input instead of data, will the image? Yes. So okay, actually yes and no at the same time. So what with images, the convention is that okay, I'll show you how that happens. So I put it in the chat box. It should be a good representation. So I have an image called, for example, the image shows you a screenshot of, for example, the commands that has to be line. Yeah, what will be in place of LLM? No, I think I can take your question without that. So for example, you have a picture, that picture that has the commands to debug a program, right? So now that's a picture. So what you want to do is, now handling pictures is not an easy task. Handling pictures, first of all, they'll be heavy on the vector database, and I don't think there is a very good way to, because images are just pixels, right? You can make correlation between pixels and text. So what you would do is, you will have assuming right now instead of 20 documents you have 20 pictures, each belong to a different thing, right? So what you will embed is not the picture but the description of the picture. So the description corresponding to the picture will be, this picture shows the commands to debug the prime number checking program. If you encounter under error A, do follow steps X, uh, yeah, I'll just clear that up. Just give me one moment. It would be follow steps Y. Yeah. So I put it in chat, right? So I'm talking about the pictures. Assuming now you have 20 pictures, saying each of them talking about a debugging situation, right? So you want to find the now again you want to be able to answer the user's question, saying I have encountered into problem error A, and what do I do? So what you will do is, you now instead of indexing the images, you will index the description of that image, right? So now the descriptions of each of those images will be embedded into the vector database. Now when the user says I ran into error A, what will happen? It will try to look for error A, and error A will come up on one of the text descriptions, right? And along with the description, at the end of the description, you will also say file path is images slash error A dot png, right? This will be probably a file path that will be appended at the end of this chunk, right? And end of the description. So when the user asks, I ran into error A, what do I do? It will try to look for all those descriptions. It will find this description as the closest one. And now with this description, you also find the file path. So it will show you can retrieve. This is a software engineering question where you get this file path, you can show it to the user and say these are the steps you have to follow. So this is how you handle images, right? So how do you handle images? By embedding a text version of it, a textual version of it, a textual description of it, putting it into the vector database, retrieving them, and then that chunk will obviously have the path to the image. So you can display that image. Does that make sense, Rajesh Kumar? Or I mean, does that make sense to everyone? Is there anything that I might have missed, or something that there was no bridge in between two things that I've said? If you could, if you were able to follow, a yes would be appreciated.
But could you explain again what we are doing after retrieving the chunk?
Okay, so you mean in terms of images, right?
Yes, sir.
Yeah. So after retrieving the image, right? So what I let me. I think maybe because I missed that part, uh, corresponding to every single. Yeah. Now I put down something in the chat box. So here, this will be one chunk. So instead of embedding the image, I embed this part, a description of the image, and the file path of the image. Okay. So now when I the user asks a query, this chunk will be retrieved, correct? From this chunk, why did this chunk get picked up? Because the description matches is the most similar to the my query. That is part one. That is how this chunk is finalized. Next part, you don't want to show the user the description, right? Because that will make no sense to him. It will say the description of the chunk will say, if you encounter A, follow steps X, and if you encounter B, steps Y. He doesn't know what X and Y are. So you want to show the image also, right? So it's like an engineering question, or more like an engineering question. It's like a software part. Now, no more machine learning or RAG, where you just pick out this is the thing that has been retrieved. So when the user asks that question, you show this file path, correct? Because this chunk has been retrieved. Now you can just render this image because you have the file path also, correct? So you'll be able to show the answer. So you'll be able to show an image to the user, which is exactly what the user wants. But you never ultimately had to deal with images. Does that make sense?
Yes, sir.
Yeah. So yeah, if that for everyone else, so does that make sense? Does that answer some of your questions? Yeah, that's great. Yeah. Okay. Okay. So a deeper dive into that, right? So again, this now this probably like a recap sort of thing. So right now I'll try to answer it over here. So I want you guys to answer. So what do you have to begin with, right? uh, this is the initially before even the user asks the question, what do you have?
Knowledge base.
Yeah, correct. So Aditya had some question. I mean, again, please don't direct message because I want everyone else to be able to see the questions too. If it is speaking only from database, then where is the ML part? No, I mean, what I meant was that it's not involved in the RAG pipeline, not in the vanilla RAG pipeline, but it's something of an engineering question, right? Where you want to design your system in such a way that you can show the user an image when you get a file path. That's what I meant. Yeah, hope that answers the question. So yeah, so what do you have to begin with? A knowledge base, right? I'll try to. That is a set of documents or set of content. Instead of saying documents as a content, it could be anything. Now, can you process them all at once? Feel free to type your answers, say it in the chat box, unmute yourself. Anything is fine. Can you or do you want to process them all at once? No. Okay. We can start with this. So what do we do?
So we split the documents that we have into chunks and then process.
Very precisely, yeah. So what we want to do is chunking, correct? We want to break them into logical separations. And chunking, again, chunking strategies, there's so much research going on with how the chunking should be done. Someone would say page by page, but if some section starts on page 1 and ends at page 2, you'll lose context of that. So page by page is not a great option in those cases. Some would suggest that there should be an overlap. Okay, what is chunking? So chunking is when you try to break a document. Any content, but for now, let's assume a document. Okay, so you have a document of 10 pages. Now, uh, page one has information about, okay, fine. Page one has information about the speaker. And then the probably the third section in page 1 starts with the speaker notes, and then it goes on until 4 pages, right? But if I process this document page by page, I give you page 1, you'll know that it's the speaker name and the section about speaker's notes. Now you forget about speaker page 1. I give you page 2. You will only have text. You will not have any headers. Will you understand what the text is? Understand that we're sending it to an LLM, so it doesn't have context, right? I give you only page 2, which has set of text. Will you understand which section it is for? Rajesh Kumar, you can just put down on chat. No, right? So, so effectively, that's what we were trying to do. Chunking means breaking your content into logical parts. Uh, Wait a second. Am I still audible? Looks like there's been a power cut here. Yeah.
Yes, yes, you're audible.
Okay, yeah. Sorry about that. Yeah. Okay. So, yeah. So, Rajesh Kumar. So, for example, what you want to do by chunking is just breaking down. For example, you have a content of 100 pages. You want to break it down into logical parts so that page 1 has information about the speaker, page 2 has information about LLMs, page 3 has information about, for example, computer vision models. You don't want to process it all at once, right? So you will break this document into page by page. So each page ultimately becomes your chunk. So when someone says what is LLM, we are going to find relationship. No, I mean we want to find semantic relationships, not logical relationships. So something we want to be able to break it in such a way that yeah, it. I mean, you are right on that level. We want to be break it in such a way that they are logical separations, right? So each page is logically different. One is about LLMs, one is about computer vision models. So if you break them in chunks that way, so chunking logic is up to you. If you make a problem, if you make a mistake in chunking logic, your RAG results will be horrible. So for example, you chunk it. If one logic match with page 10, yeah. Yeah, we do have to match it. So, for example, if page 1, 10, and 12 match with your query, you'll retrieve page 1, 10, and 11. But the LLM will be able to decide which one is the most appropriate one to answer your question. Does that make sense? So ultimately, chunking is nothing but breaking it down into logical parts so that the quality of the retrievals, when you retrieve, the chunks independently will make sense for the LLM to be able to answer, right? Yeah. So yeah, now we can go ahead. So now what do you have? So now we did chunking. Now what do you have? Okay, looks like you're still. So Rajesh Kumar, if you still want to discuss that, we can probably discuss that towards the end when you have some questions. It will try to move on and cover the remaining topics. Yeah. Okay. Yeah. So after we did chunking, what do we have with us? We'll embed it in the database. Yeah. Someone just answered, Kushi. Yeah. So that will be. Uh, Now we have chunk embeddings, and we will store them in the vector database, right? Perfect. Yeah. So will you store them as is? Obviously, no. The answer should be no. And then how that we will put it in a vector database. That's okay. Yeah. So now, why a vector database and not a regular database? I think the answer was, I think we already answered that. That is because they are in the form of vectors, right? Why vector DB? That's because they are in form of chunks, or mostly they're all vectors. That's the reason. So that we don't, because a vector database would be much more efficient in handling the vectors rather than you trying to use some SQL database or no SQL. So now we have the chunks in the vector DB. User asks a query. What do we do? I want you guys to tell me the answers for these three blanks. After the user asks a query, what do we do? I hope you guys are typing it out. Embedding the query. That's one correct answer. Okay. Then we already discussed this, right? It should be a straightforward couple of two more steps. I'm still waiting for it. Yeah, Benny Thomas, that's correct. That we have to find the match. Retrieving the chunks, right? Find match, compare with DB vectors, and find top k chunks. Correct? Now what's the final step?
Now the retrieved chunks will be used as a context, and we will pass it to the LLM, and it will give us the answer.
Perfect. So we'll give the context plus the original query to LLM, and we'll get the answer. Yeah. So that's basically RAG pipeline for us. Yeah. So again, just a quick turnaround for that question. So obviously LLMs cannot understand vectors, right? So we have to uh, get the vectors back into textual form and then give it to LLMs. That is obvious, right? Does anyone have a question in that? When we retrieve it from the database, we still have it in the form of vectors, right? We have to convert those vectors back into text and then give it to the LLM. This is just a sort of deeper dive into it. Any questions on that? Yeah, we can still discuss that. Are we good to move forward, or do we want to discuss that? A yes or no would, the answers would be fine. Yeah, how does it? So, Lakshman, so this is a it's not like a thing that, for example, you convert the text into vector. Now, obviously, using the reverse of that algorithm process or function can get back the text from the same vector. So it's like a one-to-one mapping. No two words or strings will have the same vectors. Does that make sense? Yeah, great. Anyone else has any questions over here? No, it's not an encoder decoder. I mean, you can think of it as an encoder decoder, but ultimately what it's doing is taking a string, making an embeddings out of it. Again, given an embedding, you can make a string out of it. It's just a function that can go both forward and backward. You can call it an encoder decoder, but I mean, it's just a function that converting your text into vector database vectors and vice versa. Make sense? Okay, all right. So we'll move forward. So next we have tools and tool calling. Okay. So these tools is what is making ChatGPT the superhuman that it is right now. Yeah. So when we're asking it questions, it was trying to look for on the internet and all these things. So how was it able to do that? How does it know that it has to look for the internet? How does it know that it doesn't have information on that but has to look for it on the internet? Yeah, that's what we'll discuss now. So tools and tool callings are again the foundation of where LLMs will go. Wait, someone said the slides are not changing. Um, are they visible now? I hope they are. Okay. First of all, am I still audible?
Yes.
Okay. All right. Let me stop sharing and share it again. Uh, 54th. I see it was stuck at 54. Okay. My bad. Yeah. Are you able to see my screen now?
Yes, sir.
So now, can everyone see tools and tool calling?
Yes, sir.
Yeah. Thanks, Kaushik. Yeah. Thanks all. Yeah. Okay, so tools and tool calling. Yeah, this is what we want to discuss. No, it's what we'll do discuss right now. So these are again basically, as the name says, these are the tools that makes the LLM so powerful. So we'll see how that goes. So what are tools in the context of LLMs? Tools are external functions or APIs that an LLM call to perform specific tasks that cannot handle internally. That is math, web search, and database queries. Very precisely, right? LLMs are text models. They can remember things, they can understand things. They cannot do math, they cannot do web searches, correct? Or does everyone agree on that? Yes? Yeah, correct. So, what do we want to achieve by using these tools? So, just like, for example, a simple analogy, let's just like it. I think instead of this analogy, I think something better would be, for example, us as humans, right? If we want to chop down a tree, we can't do it with our bare hands, correct? It's not something we can do. We'll need tools like an axe. So that is what we aim to give to an LLM. LLM by its own is a very good reasoning tool. It can do a lot of things, but it cannot do math. It cannot do web searches. It cannot run database queries. Yeah. So our goal is to make LLMs more useful, interactive, and grounded in real time data or system states. Like again, grounded in real time is things like uh, real time data about who won in yesterday's IPL match or what the weather is today. Yeah. So again, another analogy is just like how a programmer might Google something to use a calculator, access a database or LLMs. LLMs can use tools to extend their capabilities. Correct. So you would use a calculator to do something that you are not inherently the best at. Yeah. So yeah, going on. So why do LLMs need tools? First of all, LLMs are stateless and lack real world awareness. We've already discussed that. It doesn't know what happened yesterday. It doesn't have real time data with it. So what is the implication of the stateless nature? First of all, does everyone understand what stateless means? Some of you who might have done some sort of computer networking might have heard of it. But yeah, any idea about what stateless means in this context?
But they rely only on the trained data.
Not really. Actually, that's a different aspect. So that doesn't come along with state. Anyone else about what stateless could possibly mean? None? Okay. All right. I'll tell you. So what stateless means does not depend on current data. Conscious on its own. Actually, Rajesh Kumar, I think we meant to say the opposite. It only depends on the current data. That's one thing. I mean, okay. I think in the context that you guys are saying, it's probably different. So I think the answers are not correct. So what stateless means in this context is that when I make a call, right? So for example, uh, yeah, very precisely doesn't store past data, right? For example, uh, uh, I'm trying to simplify this example, but let's see how many of you are able to follow that. Okay, so right now, what I did here by typing google.com, I sent a request to Google server, right, for it to give me an access. Okay, let me try to find. Yeah, let me see. Hopefully, my terminal is visible. Can someone confirm that my terminal is visible? Yeah. Okay. So, does everyone know what happens if I do ping google.com? What happens when I do ping google.com? If anyone knows, you can tell me in the chat. If no, that's fine. I can tell you what happens. Okay, that's fine. So, for example, how a normal user. So, for example, the best way to look at it is it searches from where the packages come from. No, yeah, no, that's actually not correct. So, I'll tell you. So, for example, one naive way to look at it is, for example, how a normal person would check. For example, if how would I check if my internet's working or not, right? Uh, so there are two things. First, how would I check if my internet is working, and how would I check if Google server is down? Correct. So, for example, sometimes I hit Google and it's not working. Yeah. So, how do I know whether, for example, I'm supposed to blame my internet or if Google server is down? So, what I do is ping google.com. Yeah. Someone said in the chat it's ICMP request. Yeah. So, you send a request to it. So, you send to request to Google server, that is ping. Ping means you're just checking if it's alive or not, right? Google has a server where every time you hit google.com, you make a request to that server and it gives you the web page of Google that you can see on my screen. So when I hit google.com, so it sends me 56 bytes of data to this thing. So it's like, again, like someone mentioned, that's an ICMP request, right? So it keeps sending me this, it'll send me 64 bytes each time. It'll try to make sure, and the Google servers will send me a confirmation that it has received my request, which means both my internet is working and Google server is up, correct? So I'll stop this because it'll keep on going. But other than that, I have sent 28 packets of data, and this is just like a, are you alive or not? This sort of a signal call, right? Where I said, are you alive or not? If you are alive, send me an acknowledgement that you have received my packet. It's something like talking like on a walkie-talkie or something like that. So I've sent 28 packets, and I've received those 28 packets, and it acknowledged the receipt of those 28 packets. There's no packet loss, and it took these many milliseconds. Sorry, that's around 27 seconds. So ideally here, now if I do ping again, will it still continue to do that? So this is what I was doing to help you understand what statelessness means. So if I do again ping google.com, it'll start doing it again. It will not say that you already talked to me, you know that I'm alive, or you know that that communication is happening, right? It's sending a new thing. Every time I do ping google.com, it'll assume that I'm a new user trying to ping something to Google servers, correct? It will not care that I did that 20 seconds ago. It means that what I'm doing right now is stateless. It's stateless. So that's one way to look about it. So I'll close this terminal. We'll go back to the slides. So yeah, so when I make a call to LLM, it's stateless, right? For example, first I say, again, one thing that I want you guys to understand is that what we have here is not an LLM. This is an integrated LLM with tools with context. So right now, at the beginning of this context, I said, what is the name of the patient? Now, even after all these chats, I can still ask, what is the name of the patient? It'll say Catherine Yu, because this is more like an integrated all systems together LLM. But in general, if you ask an LLM, it will not be able to tell you that the patient name is Catherine, right? Because it's an individual request. It's stateless. You send a request right now, it will give you an answer for this question only. It will not remember anything from the previous call you made. Yeah. So that is the problem with LLMs, vanilla LLMs. Again, next thing is struggle with arithmetic or code execution. If I ask the LLM the whatever, 2,35,235,235th prime number, do you think it will give an answer? Someone in the chat. I mean, I'm not sure if you've tried it, but I did actually try it. I'm not, right now, either you can also try it with your own chat GPT window. You can ask it the 235,235th prime number and see what it answers. And there is a very high chance that it'll hallucinate. It'll give you a wrong answer. And how you can verify that is either actually go to a calculator and do that, or write a program to check the 235th prime number. So yeah, so what LLM does, it does not do math. It does not do reasoning on that level. What it does is just find whatever it has learned. So again, there is a very high chance that it will have a bad answer to this. Yeah. So coming to the next questions, it can access real-time data or external data by themselves. So if you ask an LLM about today's weather, again, it will not do a good job. So ideally, we'll come there. But whenever I say what is today's weather, what this essentially is, this is searching the web. This searching the web is a tool that this LLM has. So now we are able to access what this is. Right now, I'm based off in Pune right now. So it can say that today Pune is 96. So what it did was, when I asked today's weather, it understood that, okay, this person wants to know the weather today, and this person is in Pune right now. because it based on my IP or whatever. What it did was then it sent all this information to a weather tool, which actually finds the weather based on the city and the time. Then it was able to give me this thing. So we'll see how that happens. And again, tools help us LLMs to interface with the outside world like a plugin system. So for example, if we ask an LLM, give it access to the database and tell it find the customers who bought the most number of items, something like an Amazon e-commerce system. It'll be able to do that if you give it the right tools, correct? So now we'll see how these tools, what the foundation for these tools and how they happen, how we can allow them to interact with the LLMs. So first, instead of making LLM do things, we want them to decide what to do and when to do something. This is actually a this sounds like a very layman sentence, but this is the complete foundation of what tool calling is. LLMs may not be able to tell you what is the 9,000th prime number, right? But one thing that they can do very well is know that you are asking for calculating some n number prime number, correct? Nth prime number. That is something they can do very well. You can give them in any form. You can make a spelling mistake, anything. They'll do a very good job at understanding that that's what you want. So we are just linking them with a code. So for example, now it knows. For example, you say what is the 9,000th prime number. It will detect that you are asking for an nth prime number. It will check in its tools. You will give it a set of tools. I will give it a set of one tool is checking the weather, one tool is checking whether a number is prime or not, one tool is checking sorry wait my screen is still visible, right? Okay, looks like I lost it in the middle. um, yeah, I hope it's visible now. Okay, yeah, cool. So yeah, what we're giving the LLMs control is to, for example, access all. So I'm giving the tools to find today's weather, to find out the nth prime number, to do a web search. It can absolutely very well, even a very small or relatively low parameter LLM can do is that recognize that I want to use the nth prime number tool, correct, and not the weather tool and not the web scraping tool to answer this question when I ask about when I ask about the 9,000 prime number. So that is what we want to leverage. This gives us so much more control on LLMs, what LLMs can access by having to do us deterministic actions. For example, you don't want the LLM to even accidentally delete all the rows of a database, even if someone asks it to do that, right? For example, you have an LLM that is being the interface between you and a database. You can ask it, for example, you're asking a set of queries. Maybe at some point it misunderstood what you said and said delete all, and it tries to delete all. You don't want it to do that, right? So through these tools, you can even check what things it can do and what things it cannot. You can control that. So with these features, tool calling makes LLM so much more powerful because it's a skill to do a task that can plateau over time, but to make a decision is much easier. If you want to teach an LLM about finding out the prime numbers, you can't teach it everything. First of all, because it cannot do reasoning on that level, right? What it can do is understand that we have to do some things and invoke such tools, and then the tools can take care of the rest. Because finding the 9,000th prime number by code is just 3 lines of code. You don't want to end up making the LLM do that, correct? So moving on to the next part. Yeah. So when I tell ChatGPT, this is the standard structure. If you want, I'm using ChatGPT, OpenAI as an API. So what I'll do is I'll tell that you have access to a tool called Get Weather. For example, look, I tell the chat. Okay, let me put it in the chat box. User query. No, actually, first we'll give it a set of tools. First, the tools that LLM has: Get Weather, Find, and okay. So I give you the tools. So we tell the LLM that these are the two tools that you have access to. That is Get Weather and Find nth prime number. Now the user asks a query. User's query. Sorry. What is the temperature in Pune? Yeah. Now let's see. Now what happens? Once the user asks this, what will happen? Can someone say it out loud? what could potentially happen. Any no updates? Okay. So I think the flow is already written here. So I ask, what's the weather in Paris? So available tool is that it'll understand that the tool I have to invoke is the get weather function, correct? Because it's not in any way relevant to the nth prime number, finding the nth prime number. This get weather tool is what we want. Now the following things happen. The user query is sent to the LLM with the required schema. And the schema looks like this. Okay, the get weather. Now it understands the according to, now I only gave it one question, that is what is the temperature in Pune, right? I mean I just change it to Pune so that to maintain some consistency. Yeah, so it will say, it'll understand that city is Pune, correct? It'll form this structure. Now there's one more part of it. Let's assume that the get weather function needs two arguments, right? Two arguments such as uh, a weather to Pune. For example, the city, that is the place where it is, and the time, right? Because the weather can change from now to 28 hours later, 24 hours later. So it also wants the time. This get weather function. Now, what it can do is, for example, if you want to check the weather right now at your place, what do you guys do usually? Someone in the chat box can unmute and tell. You want to check the weather at your locality today, right now. What do you do? Google it. I mean, yeah. So that's the first thing that comes in mind. So yeah, again, when we say Google it, we can just go to weather.com, right? So there's this thing called AccuWeather. These things give you APIs, correct? So I can check that right now in my locality. Yeah, it's 34 degrees. So how many? Yeah, weather widget, correct. So all of the widgets that you can see, even Google, all of it is linked to the APIs. So I'm assuming Pune, Maharashtra right now, it's 34 degrees Celsius, right? Now, what are the two things that you need to get this temperature? What are the two things that can uniquely identify the temperature at a location? Can you tell me? Okay, is it only the location? This website, I'll assume that it gives me APIs. It gives me an API which I can make an HTTP call to it, and I can get the weather at any point of time. What are the two parameters that I need to pass? I want you guys to answer in the chat box. No, that will be the output, right, Rajesh Kumar? What's the input? What do I tell it? What will be my query? Yeah, very absolutely. Location coordinates, that's one aspect. Date and time and location, that's the answer I was looking for. So we need both the location, where do I want the temperature for, and when do I want the temperature for, right? That's the most important parts. I don't think there will be any other parameters, or if at all you can do that. But time and location are the most important things. I want the temperature in Pune right now, or I want the temperature in Pune 2 days ago. So that's what we want. Now we will give LLM that functionality based on my question. My question was, what is the time in Pune? So it figured out that the city is Pune, correct? It formulated this part, this JSON, this structure. But my get weather function accepts not just the city, but also needs the time, correct? Sorry. So what I will do is, I will append, because the user did not mention any time. I will assume that he wants the time right now. So how many of you are aware of, are used to Python as a programming language? Do a good I think, yeah, I mean, it's not like we're going deep into Python. So what we'll do is, there's this time module in Python, right? There's a time module in Python. We can find the current time. So if you want to see that, I can say, for example, I'm in the Python shell. In the Python shell, I hope it's visible. I can just type import time dot time. So this is today's time. So this is a Unix time. So this is where let me see it. 1 second. I think I lost track of that. Yeah, so this is the time right now. And I mean, you can obviously split this out. So this is basically all the time that has been passed until, this is the number of hours or seconds that has passed until since 1990. So you can always parse it back into, let me see if it's I can kind of good way to go about it. Parse time dot time into data format. Yeah, so I mean, for you, if you want to do that, I can always do. Yeah, I get the time, and then if I want to, this is all I'm doing. So until here I did that already. So all I just want to do is convert it into a format that we all understand as a human, not just as a Linux timestamp, right? So if you find DT, it is 31st May 2025, 3:42 p.m. Correct? This is taking my system science or probably IST right now. So this is what we have. We can string this, combine this string and put it into a format as such, right? That is what we'll do when we give it to LLM. So we will join today's time to that, okay? Now we have successfully created all the parameters required for this get weather function. Now, this is like a really interesting question. Do you think the LLM executes the get weather function? So assume that this get weather function makes an API call to accuweather.com through an API that they provide, gets the results, it gets as a result the temperature at that point at that time, and then gives it back. Do you think this function is executed by the LLM? Yes or no? Making this API call and getting back the result. We know that it has tools. It knows that we have to call that tool to get the weather. Does the LLM actually execute that function? What do you guys think? Okay. Someone says yes. I would like to hear some more answers from you guys on this. Okay. So you think an LLM will execute that? Yeah. Okay. So unfortunately, the answer is no. The LLM does not execute that. See, so here you again have to think of LLM as not someone who can execute code, who can do all these things, but as no. So Aditya, LLM does not invoke that function, but LLM knows that it has to invoke that function. What our code invokes that function. So how the flow would be is that I give. I think we'll just continue my previous answer. Let's see if I can do that. Yeah, I think I'll be able to properly tell you what happens here. Yeah, so I said the tools are that these are the tools that we LLM has. I give the user what is the temperature in Pune. It creates the JSON city Pune time 31st May. It creates this JSON, correct? Then it knows that get weather is the tool to be used. Then it tells me that this is the tool to be used. What I will do, my code, because see now I'm not doing anything hard coded. I'm not hard coding that we have to use get weather. Let's see the LLM response. Tool to be used. And data is equal to this. This is what the LLM will return. So I'm not hard coding. You might think, what if the user asks for the 9,000th prime number? Then it will give me a different data and different tool to be used. All I have to do is run tool to be used data. Do you guys understand what this run thing will equate to based on the values? Because see, the most important point that you would understand here is that I'm not hard coding this function, this code, the last line of code that I've written, run tool to be used data. I'm not hard coding that. The LLM gave me that. I just have to execute it because LLM cannot execute it. LLM does not have a CPU. LLM is just a next token predictor. But I'm using the answer it gave to make sense of it. Can someone tell me what will happen to that run tool? What will be the substitutions and what will ultimately run? when I invoke the last line of code. Any answers? You can think about it for a while. I think if you understand this part, I think even if you take away this part of it from the entire presentation, that will be great. Yeah, perfect. So Swapnil, you're absolutely right. So that's exactly what happens. So by run, it means we're executing it as a Python code, not as a single script. So exactly this is what we want. And now tool to be used as is an object of getWeather. So Sai Abhinav, it's a reference to that function. So getWeather is a function. It's a string. Tool to be used will always be a string because LLM just returns you strings. But you know that the string corresponds to a function, correct? Let me see if I can quickly put down something that's clear to understand. Python. Uh, okay. So for example, I have a function called def uh, get weather. For now, what I will do is, for now, I'll keep the arguments empty for the sake of simplicity. Okay. I will do return 38. Okay. Or yeah, return 38 degrees Celsius. That's the function that I have defined in Python. Now, the LLM, for example, after all my invocations, LLM gave me that the function to be executed is a string called get weather. Get weather is the function that I have to execute, right? Now, to answer your question, Abhinav, what is get weather here? I want you to answer. What is get weather here? A string. Perfect. So it's a string. And what is what is this definition? Uh, this part. Can you tell me what this part is? The part that I've highlighted. It's a function. Perfect. Yeah. So that's a function, and this is a string. And this is what the LLM told me that I have to use this function. What I can do is okay. Let me see if there's a better way to run it. Okay, I think that's stuck. Let me see if I can make sense of that. Yeah, let me see. Yeah, actually, I figured it out. Okay, cool. Let me clear that up so that I can give you a better example. Yeah, so I'll just quickly write the weather again. Get weather. For the sake of simplicity, I'm keeping the arguments empty right now, and I'll say return 38 degrees. Okay, so now the string s would again be get weather. So that will be the s, right? Now I want to execute that function. Again, LLM cannot execute it, so I want to execute it in my code. So my code flow would be whatever this result. So this could be get the nth prime number, and the function would also be there. But right now the LLM return get weather. So I can do eval, and that is me saying, me telling Python that I want you to evaluate the following piece of code as a Python script, not as a string. So what I can do is f string. I mean, for those of you aware of the Python syntax, I'm just making it a string where I can say that it's s, then it's a function, and closing it. So it returns 38. Do you see what happened? I mean, I kind of hope that you got the intuition. If anyone is still not there, I can go at it again. You can check, confirm in the chat box if that makes sense. So I'm dynamically executing what the LLM asked me to execute. The LLM cannot execute, but it's just telling me what to execute. And the execution can happen because this get other function, it doesn't need an LLM. It can make an API call, it can return 38, it can actually be hard coded. Anything can happen. This is how tools are given to LLMs. So you can even give LLM tools to, you can have a function that does clear all DB. All right. You can also have a function called definition of I don't know, print max consumers or max products. You can give LLMs all these tools, right? And then the LLM will tell you which one to use based on what the user asks, and then you can execute it yourself. So you're doing it intelligently. Does that make sense to everyone? We're getting a few yeses, but a few more confirmations would help for us to move on to the next part. Yeah, that's great. Good to hear. Right. Okay. Yeah. So going back to the slides. So yeah, again, these are the foundation of every tool calling architecture. These are how tools are called. They don't execute the tools. They just tell us which tool to execute because they're best at doing that. So as
Yes.
mentioned, yeah.
So
Yeah. Please
why
go
were
ahead.
we unable to run the get weather thing?
I didn't understand. Why were you unable? You
Sorry,
mean?
you asked us that will we be able to run this code about the get
Yes.
weather?
Correct. So, like I said, LLMs. So, for example, okay, tell me one thing. Here, I said I'm in a Python script. I said print hello. First of all, why am I able to run this code? I mean, let's go to the super basics. I mean, to run this code, what do I have to? What do I need to have first? I need a
Print
machine, right?
statement. Yes.
No, I need a machine, right?
Yes, sir.
I need a compiler. I need a CPU. I need a compiler. Yeah, correct. So I need that to execute this part of code, correct?
Yes, sir.
Correct. So I need to have a CPU. I need to have a system to do that. Now, an LLM is a model, right? Does it have all that? I mean, this might be very counterintuitive, but I mean, it's as simple as that, right? You don't have your LLM does not have a system. It doesn't have an interpreter. For Python, it takes an interpreter. Does that make sense? It cannot run that
Yes.
code. It can tell you that you run this code. This code will get you the weather. This code will give you the nth prime number. Does that make sense?
Yes, sir.
Yeah. Okay. Great.
So how will we fix this then?
How will we fix this in? No, I mean, we're fixing it by tool calling, right? Now I'm asking an LLM. The user's query is find me today's weather in Pune. It is telling me that these are the tools. Get weather is a tool. Get nth prime number is a tool. It will tell me use the get weather tool with these arguments, and you'll get your answer. And I will run that using the eval function that I showed you.
Yes, sir.
Make
Understood.
sense? Okay. All right. Yeah. So okay, let's go ahead. All right. So next, again, like I said, tool calls are like steroids for LLMs. Yeah, that's what makes them super powerful. And this allows us to interact with the real world, and it also forms the basis for to use LLMs as agents. Yeah. All right. So yeah, again, as usual, we have a few challenges with using this as a complete if right. So for example, one is LLM hallucination. So sometimes it might call the wrong function. For example, if the functions are too close, one is for example, you're running an e-commerce system and you're running get max products or get max users, right? They might end up being similar. Potentially, the user's query, if at all, he makes some spelling mistakes and he phrases his word wrong. There might be some hallucination or a different function may be called up, right? So that is always a problem with LLMs. Then there's schema adherence. Now tell me one thing: if the LLM were not to, for example, it made a mistake in generating this schema, right? This function accepts this schema as an input. For example, it made a mistake and forgot to put an apostrophe here, right? My code will fail. My code will throw an error. Correct? Does everyone agree with that? because this has to be a JSON, correct? My function accepts a JSON. Yeah. So if even if it miss out that one single apostrophe, my code will fail. So schema adherence is absolutely important. We have to make sure that adheres to the schema that we mentioned. That's again one of the challenges, and again is planning. So now a single LLM may struggle to keep a multi-step tool. Yeah. So for example, you want to find, for example, find the first you want to first, for some reason you want to do such that you want to find the 9,000th prime number and then find the sum of all its digits. If you ask an LLM to that, the 9,000th prime itself, it may not be able to do a good job. But if you ask it to do these two consecutive steps, it will not do a good job. It'll almost always fail, right? Sorry. So that is something that is struggle with. So that brings us to the origin of agents. That is probably, I mean, how many of you have heard about agentic AI around you nowadays, either in the news or either in whatever you've been working on? I'm expecting a lot of yeses right now. Right, wherever, I mean, one very for example, if you recently look at all the talks with CEO of Microsoft, Satya Nadella, or anyone, whenever even you talk to some recent podcasts or lectures by the CEOs of these major companies, all you can hear is agentic. It's as if agentic is finally going to solve everything, right? So we'll discuss a good part of it and see where that goes. Yeah. Okay, so agents. What is an agent? Some of you might have taken the course on artificial intelligence and something like that, but even before LLMs, agent is just an intelligent system that can understand its environment and take a decision, right? So agent, so right now we'll talk it in context of an LLM. An agent is an LLM based system that can understand the task, decide which tool to use, plan a sequence of actions, and execute these tools iteratively to achieve a goal. Does that make sense? Does that fit into the definition that we've set until now about with tool calling, LLMs, and the sequence of actions? Yeah. Okay. All right. So next we have an analogy. So it's like a agent is like a software intern, right? Who understands high level goals, tries to figure out to solve them step by step. Yeah. That is how an agentic setup works. So first of all, why agents? If we have these LLMs to do this, we can give tools to LLMs. What's the difference? Why do we need an agentic server, right? So the reason we need it is that the bigger advantage of using agents is to allow scope for rectifying what an LLM generated. Okay, so now tell me one thing. Uh, I can show a visual example. For example, uh, yeah, you can look carefully. You can look carefully what's happening. So it started generating from here, is prime, and find the nth prime number, right? Now, do you think there is a way, for example, here it made a mistake and it forgot to put an double equal to, instead it put a single equal to? Do you think it can go back and change it? I've asked LLM, right? It can just start generating. Do you think it can change? Yeah, as someone said, Swapnil said, yeah. So we absolutely cannot change it, correct? The reason is uh, because it's in a one way thing. Once it starts generating, it starts generating. You cannot go back and change something. So this single-handedly is the only major problem that we have with making single calls to LLM. Right? There is no planning. There is no we have to explicitly tell it to do so. No, actually, Swapnil, even if we tell it to explicitly do so, it cannot do that. Right? It may potentially right now, if I ask it again, oh, you forgot an double equal to, can you put that? It can do that, but it cannot go back and actively change its current answer. Correct? Yeah. So that's the reason we need these agents, right? That is the reason we want an agentic setup where there are multiple intelligent agents. In this case, there is only one intelligent system, that is the LLM. I'm making one call, it is giving me answer in one shot. Now assume I want to tell it, nowadays LLMs are able to do that. Now I can tell it, build a full stack, a fully functional uh, e-commerce website, right? So I mean, I'm not going to do that because I don't know what it'll generate. But for example, you understand that a fully functional e-commerce website will take a backend, a front end, a database systems, user models, and all these things. I don't know, maybe 10,000 lines of code. And once it starts generating, nothing can change, right? Once it starts one function, you cannot go back and change that function when you realize that, oh, I should have made this function accept so and so parameters instead of this. So there is no scope for rectifying mistakes that it already did. So even if I tell you, you can never use the backspace and you have to write code, you obviously will not do a good job, correct? So that is the most that is the reason for using agents, a multi-agent setup. So like I said, an example for an LLM to build a full stack application. The problem is that it will try to do everything in one shot. Even if it realizes that it made a mistake, it cannot correct it. So even for reasoning tasks, an agentic setup will ensure that one agent made a mistake. It can be rectified in the later iterations by sending out the correct answers, right? Before sending out the final answer. Yeah. So we'll move on. A very again relatively simple but easy to understand example. So assume you want an agent to generate a response, and we need it to be a perfect JSON, correct? Now, again, the reason it's difficult for me to show these demos is because now we're in GPT 4.0, where 4.0 is very strict in terms of adhering to the instructions. So if I ask it to generate a JSON, it will almost always generate a perfect JSON. But let us try to understand a scenario where that's not the case. Yeah. So I'll try to explain it as best as I can. So ask it to generate a JSON. Give me patient details. All right. So let's assume there's only two fields, that is name and age. Yeah. So does everyone agree that if I ask it to give it to me in JSON and give the correct information, it will give me this, correct? Does everyone agree? Yeah, absolutely. So you kind of summed it up, but yeah, let's go step by step. So this is what it will give me. Now, assume that I gave it a patient information or information from a medical document that is what, some 100 pages long, right? And I expect it to extract 100 fields. It will not do a good job. Sometimes it will give so many fields, other than fields. Sometimes it will forget an apostrophe. Okay, it'll forget a comma, for example. Okay, because I'm doing asking it to do so much in one shot. For example, it forgets a comma. In a regular without an agentic system, it will just return me this, correct? And I have no way to understand if it's correct or not. When I will try to load this JSON, I'll find an error, and then I'll have to go back to their LLM to fix it. Correct? Or does everyone agree that potentially it can make a mistake in forgetting the comma, one apostrophe, or maybe instead of age it says age, accidentally misses a small letter. Yeah. So these things can happen. Now let's assume that it forgot a comma. Now in an agentic setup, what will happen is there'll be one agent called JSON checker and another called JSON fixer, right? Now these two will work harmoniously. Now this is the answer that I got from my LLM. Now I will give it to this agentic system, not just one, but this agentic system which consists of two agents. The agentic system will be configured in such a way that my answer, this is called result will go to this agentic system. Okay, inside this agentic system, first it will be passed to JSON checker. JSON checker will be result. It will say it's an invalid result, invalid JSON. Then the result is passed to JSON fixer, which will fix the JSON. Correct? Which will fix the JSON. But do you again? So again, see, let me tell you that this JSON checker is an LLM. And this JSON fixer is also an LLM. Correct? So now JSON fixer, even that is an LLM. It can also potentially make mistakes. Correct? So in the case that, let me try to see if I can extend this. Now there are two situations after the JSON fixer returns, right? After the JSON fixer, if the result is something like this, yeah, for example, it fixed the comma, but now in turn, when generating this, it forgot this apostrophe. Yeah, what will happen? Or let's first discuss the scenario where it's correct. Right, this is correct, but we have no way to check it. So again, this is passed to JSON checker. Again, now the JSON checker will say it's valid. Now it will come out of the agentic system. And we can get the answer. And we can be absolutely sure that it is the correct answer. Right? Two-factor authentication. I mean, this is what I'm telling you as a simple example. But in case of software development and some other systems, you can have like, very huge, very, potentially groundbreaking paradigms, right? Like if you could say so. So let's consider the other scenario where the JSON fixer did fix one part of it, or for example, for due to some reason was not able to fix it, or made another mistake. It will again go to JSON checker. It will say that it's invalid again. And again, it will go into a loop. Now it will go to JSON fixer. It will try to fix it. And it will keep on happening until there is a correct valid output from the JSON checker. So this way, we are leveraging two intelligent systems to work together, or two or multiple agentic systems, intelligent systems to work together. That is why we call it an agentic framework or agentic system, where multiple intelligent agents work together harmoniously. Yeah. All right. So a comparison, plain LLM, right? This is what we do. Then there is tool calling. Then there's agent. These are the three paradigms we discussed, correct? I hope we're clear on that. So to understand a task, all of them can do that. Use external functions. Plain LLM cannot do that, but tool calling can do that. Again, when I say tool calling, so agentic systems are also LLMs? Yes. So Aditya, so there's two options. In an agentic systems, I mean, honestly, yes. In our setups, agents are also LLMs, right? Agents are intelligent systems. So yes, in our example, they are also all LLMs. Does that make sense? Okay. So yeah, using external functions. Can a plain LLM do that? No. But with a tool calling, we can do that. And obviously, an agent can do that. Multi-step reasoning. This is where things start getting worse for the other parts. Again, none of the future things a plain LLM can do it. Now, when it comes to multi-step reasoning, again, here we are giving it the appropriate tools. But can it plan? Can it make mistakes and rectify them? No. So it's pretty limited, the reasoning. But agents can do that. Select tools dynamically. Again, in case of tool calling, it's kind of hard coded, but agents can do that. An agentic system can do that. Keep memory and state. Again, none of these can do that because, like we discussed, it's all stateless. But an agent can do that. Executing and planning, again, same. No control in the flow. A single tool calling has no control, but an agentic system obviously has all these things. So one question is, what if we use JSON checker and fixer as only tools, like only as a function? Yeah, actually, that's I was coming to. Swapnil, that's really a really good question. We'll come to that. We'll absolutely come to that right after this slide. So Shambhavi, yes, GPT. So okay, so ChatGPT is an agent in our context, yes, but an agent is defined as an intelligent system that can take decisions, understand the surroundings. So yes, ChatGPT understands what we ask it to do, and it can take some decisions. So it is an agent, yes. So it is a nested elements where one LLM's output is input another. Yes. In the sense they work harmoniously. It's not always necessary. So it can also be that one agent is working on, for example, one agent can do really good programming, whereas the other agent can do really good planning. So one agent will do planning, one agent will do coding. So not necessarily that they are using the output of each other, but they're working harmoniously. So that's why we don't say that we don't like are not restricted to input output, but rather working harmoniously, using each other's thoughts, using each other's outputs. Hope that answers your questions. Yeah. So here we can see that planning and execution is something again. So for all of these things, agents is something that can take care of all these situations. Yeah. So the main overview of typical agentic architecture, it has the following components: an LLM, which is to answer your question, Shambhavi, is again an agent for reasoning and generation, a tool set, available functions and APIs that it can use, A planner, which is also an agent which generates a step-by-step plan. An executor, this is often implemented programmatically, yeah, because in Python, Java, whichever language you're using, because it has to decide what happens next. And then the memory, because everyone has to maintain context of what has happened until now. So that's really important. Agents cannot be stateless, else they'll not be in point of using harmoniously. The core loop, like I said, is a React loop, which says, by React I mean it's an acronym which says for reasoning, acting, and observing. So first we receive a task, find the cheapest flight to New York to Paris. Next action, first we have to do the search flights and filter options. So first it will do the search flight from New York to Paris, then it will do the filter option and do the cheapest first. Then the call tool, that is book that flight, right? We observe the result, we'll get a lot of flights, sort it, query it, and then book it. And then the final result is you already booked the first flight. So this is like until here we were reasoning what to do, when to do, then acting, calling the tools, observing the results, and then returning the final output. That's the core loop of an agent. Yeah. Challenges in agentic systems, right? So one thing is LLM hallucination may make up tools or misinterpret as outputs. Yeah. Again, that's always a problem. Infinite loops. Now imagine that JSON checker and fixer. That's a perfect example to describe this. What if the fixer is horrible and it keeps messing up things and the checker always keeps on returning invalid? We'll be stuck in an infinite loop, right? So we need some sort of fallback mechanism that after 5 tries just quit the operation, that we're not able to do it. Latency, again, since multiple agents, you have to understand that there'll be latency involved, right? It'll be much slower than basic tool use because there'll be multiple steps, each of them can do these things. In ChatGPT we can go to history of our chat. So here, yeah, so Aditya, really good question, but what happens here is that uh, it's really difficult for us to understand this in context of ChatGPT because ChatGPT has a lot of systems involved. It's giving you tools. It has an internal tool for web scraping and all. But like you said, this memory is what we're talking. This is the memory we're talking about. But a normal LLM will not have this memory. ChatGPT is maintaining it for us. Got it? But yeah, it is storing it in its server database or our client side systems, probably in our system only. But yeah, that's what it is doing. So one really important thing that you need to consider is that the chat gpt that you're using on the web right now is not an LLM. It's like a super LLM it's like a LLM that has all the tools, all the internal functionings and things like a database and all these things. So it might be difficult, but you have to understand LLM as a token generator, not as a chat gpt that we see online. Yeah. So again, testing is hard. We have to find out which agent did messed up and which agent messed up at which point, right? You have to understand because otherwise you'll not know which agent actually gave you caused the problem, which propagated forward. And finally, maintaining observability. It's the same as before. You have to understand which agent is doing which part of the reasoning. So it's difficult. So you have to print out and maintain a separate log for each agent, saying, okay, this part was doing that. It was the reasoning that it had. Yeah. So one other thing, I think there was a question that we were going to get back to is that what if we use, Sopler's question where we said, what if we use JSON checker and fixer only as tools, right? Only as a function or tools. So that's what I was coming to. So here, one thing we need to keep in mind is that agentic is not the only way, correct? So before agentic, obviously there were multiple architectures. So like you said, it is possible to implement this using JSON checker and fixer only as tools, not as an LLM. But the only concern with that is much of the hard coding will be done by you. So it will not be a very what do you call that, independent process. Yeah. So you will have to tell it that first do a JSON checker, then the fixer, and then checker again if it's invalid. So you will need to work. You will need to write more code than the LLM is working on. But if we implementing in the agentic system that we did, that I explained right now, the agentic system will be doing work for you than you. Correct? You'll not be coding it out. You'll not be hard coding the logic. You'll not have to code an infinite loop and ensure all these things. Correct? Does that make sense? Yeah. So yeah. So that's about it. And then yeah, we finally have any more questions. So I think that's the end of the presentation. Correct, software. So it's making our West lesser. So if we only have one LLM call and two tools, we're still having to do much of the decision making. But if we have two agents, they will do the decision making instead of us. So there is no hard coding involved. Got it? Yeah. So yeah, I mean, any questions you have, you can go ahead. And yeah, I just wrap this up saying, so just a few acknowledgements. So this is a friend of mine. She's doing her master's in computer science at Illinois, and she helped me with this presentation. So just as an acknowledgement. So yeah, back to our questions. If you guys have any questions, anything, you can just put them on the chat box right now. Where do you learn? Yeah, that's a great question. So there is a few things that I can recommend which I've personally used. So I'm not sure how many of you have a computer science background, or what sort of or what backgrounds you are from. So I just put down first thing, in order to get the basics of machine learning. I feel even before you get into LLMs, understanding the basics of LLMs is crucial. So for that, I would suggest Machine Learning by Andrew and G on Coursera. I think you might have heard this a lot of places, but again, that's the first thing that I would suggest everyone to do. And then after that, yeah, if you want to learn more about LLMs, you always have deeplearning.ai. So this is a really good. They have short 1 hour courses, which will get you to all this agentic, all these hypes, about agents, about agentic frameworks, all these things. So it will give you a 1 hour introduction about all these things. So how can a linguist make use of LLMs? I'm unfortunately, my background is in computer science, not as a linguist. So I mean, I'm not sure I'm in the right position to answer that question, Lakshman. So Rajesh Kumar, is it free? Yeah, absolutely. So the Coursera, so both the ones that I suggested, unless you want a certificate, you don't need to pay for them. So the Coursera one, you can do it for free, but if you want a certificate, you might have to pay for it. And even the deeplearning.ai courses, all of them are free. Yeah. So Swapnil, just a curious question: why are you using Linux? I mean, depends on what majority you're talking about. So I think if you talk to programmers, I think everyone will everyone will use Linux, because Linux for programming is a much more convenient tool. You can do everything in command line, and yeah, I mean, for example, I mean, I'm not sure if you're aware of that, but even when you're accessing VMs and all, you don't always have GUIs, right? You can't open VS Code in a virtual machine and try to code your way in. You have to learn how to use Linux to get used to that. Abdul, is the Coursera course good for? Absolutely, yeah. So one thing I would say though is that the Coursera course is slightly math intensive, but I assure you that if you're able to follow that math, it'll really help you big time. Even if you spend some time, even if you take 2-3 weeks, 4 weeks, or even much longer to get that course properly done, you'll learn much more than you would learn from any of these courses which do not involve math. What if we are not good at deep learning concept? We have an idea and want to learn LLM. Can we? I mean, you can always learn LLM. So right now, the pace at which LLMs are growing, no one can keep up. I'm pretty sure no single person can keep up with all the advancements that's happening, right? But deep learning concepts would help. But I mean, if you're not really comfortable with that, you can still go to LLMs. Totally fine. Yeah. Can you brief the roadmap for LLM? I mean, that'll take slightly more personalization. I mean, first of all, I think your first question was LLM in medical image processing. So, Rajesh Kumar, I think we're a long way from using medical images in LM. So, I mean, there's definitely you can, Gemini models and all claim to do that, right? You can give it a medical image and it'll try to make sense of it, detecting fractures, detecting cysts, detecting abnormalities. They can all do that. But I think computer vision, because they're all medical use cases, you need to be really sure about your answer. So I feel computer vision is the way to go right there as of now. But we'll see how that comes up with how LLMs will improve to have more observability, explainability, and reliability. Right, that's one area of research. And for the roadmap, I think, I mean, you guys can all reach out to me. I mean, fortunately, I have a unique name, so you can always reach out to me on LinkedIn and ask any questions you have. I think I might be able to give you a more personalized answer on that, because I mean, for even as a beginner, I think everyone will have a different situation. So you can just search that name up. You'll find my LinkedIn. You can hit me up. Yeah. What's the most beginner friendly way to learn PyTorch, TensorFlow, and so that again is specific answer. I mean, you could start with something like first of all, you can do Andrew Ng's that machine learning course that will help you get started with machine learning. And then if you want to get into PyTorch, some tutorials like building an NN from scratch. There's a very popular course on that, building NN from scratch, where you implement all the back propagation, forward propagation. So that will help you get an understanding of how PyTorch works. Yeah, hope that answers. Then libraries related to transform that I can implement in Python. Um, so for that, so Lakshman, for that, I mean, if you want to implement them in Python, you can always do it. They're all open source, so you can have Hugging Face, Transformers, Olama. These are all really nice libraries that you can check out, and they'll really help you understand what's going on underneath. Yeah. What are the expectations from the company? Well, as we are a beginner and get placed into data analyst, I mean, it totally depends on the company you're hiring for. But I mean, but as a beginner, I think what I would suggest is, I've taken a few interviews for people who've joined my company, but what I would suggest is that even if you know a few things, get a really solid grip of the basics, like the machine learning, the math behind it, what really happens in back propagation, what really multi-head attention, global attention means. Even if you're able to muster up all those basics and know them properly, and the actual under the hood workings, I think you should be good to go. You're in a position to learn more at a company. Yeah, okay. Can you go through some codes? Yeah, so actually that is something I was hoping to get to that today, but I mean, looks like we took up way too much time with RAG and agents. But I can try to send for the codes part, I can send some codes or some useful examples with this mail. I mean, so Naina, is it possible that I can share some resources which you'll be able to forward to all the participants? Is that okay? I can share it to you by evening or so. Yeah, I think we can. I'm hopefully you can do that, or else let me see if looks like Sunaina, am I audible? Are you able to check that? Okay, looks like she might be away from keyboard. That's okay. But yeah, I mean, I'll try to get in touch with Sunaina and make sure that she is able to forward all the required resources to you. So I can send in some codes and some useful websites too. Yeah. So can you share your email ID? I would prefer. I mean, if I give you the direct email, I think it might get out to a lot of people. You can just hit me on LinkedIn. I think I'm pretty active on LinkedIn, so you can reach out to me there. And after that, I mean, if the conversation moves forward, you can always go back to your email ID. Yeah, I think with emails, I think they'll be too flooded, right? I think LinkedIn would be much easier to handle for me too. Yeah. My LinkedIn. I mean, yeah, you can all. Okay, let me paste the link if you want. Uh, yeah, I think someone just posted that. Thanks, Swapnil. And yeah, I mean, you can also check out my personal page. You might find some resources over there too, if any of you are interested. So yeah, that should be it from my side. You can get more questions if you want. Yeah, I'll be hanging around. I think we still have 5 minutes more. I'll be here if you guys, anyways, if you want to ask any questions, you can. Yeah, but I mean, I anyways have you guys have my LinkedIn, so you can reach out to me anytime. I'm pretty active there. Yeah.
Meanwhile, I'd like to thank you so much for joining us today.
Yeah. No problem. It's been really nice. It's always happy to teach students.
Okay, so we'll be waiting for 5 more minutes if they have any questions, so they can ask you.
Yeah. So yeah, so like I was saying, hopefully, I mean, it might be take me a while to gather all the resources, but if I can send you a few emails, will you be able to forward to all the
Sure,
participants?
sure. That will not be a problem.
Okay. Thanks a lot.
Okay.
Lakshman, I mean, job opportunity. I mean, you're asking about in the place where I work or in general, I mean, you can always reach out to me for LinkedIn on LinkedIn, for any personalized things. What course should I be following for machine learning? I've just completed. So Abdul, I mean, if you're in your first year, I would say focus really on probability, statistics, and linear algebra. I think if I were back in my first year, I would have paid special attention to them. If you do that, I think over the course of, I mean, by the end of your second year, I think you might be in a position to really understand the math behind machine learning and start with, like I said, Andrew Ng's machine learning course. It'll help you learn a lot of math. Can you please share a roadmap? Uh, 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 okay, I mean, yeah, Rajesh Kumar, for a roadmap, I would say, again, if you're not in the CS field, you can again start with the basics of linear algebra and probability and statistics so that you understand the foundation of these models. And then you can gradually, go into machine learning courses and all. So yeah, a little bit of so if you're completely out of CSE, I mean, you can start by learning a bit of coding, and I would say Python is the way to go. You can start with Python, understand libraries. It's an intuitive language. You can start with there and see where it goes. So Lakshman, yeah, definitely. I mean, if you're looking in general, I mean, you obviously have jobs over here, right? So it's always good. So as long as you're good with the basics and you have a strong implementation, you have skills to implement and all, it's perfect. So you'll have to work on that. Yeah. Libraries. So I mean, libraries will come as you go, right? Yeah, there are a lot of libraries, but I'd say you can start with PyTorch is one to do. So PyTorch and Tensor. So you have to look at which ones you want to go through. PyTorch is the state of the art library, if I'm not wrong. TensorFlow is almost TensorFlow is not something a lot of people are using. Yeah. So you can start with PyTorch and understand the libraries as you go and see based on your use cases, based on what you're learning. And I'd say instead of learning a library, it's about try to build an application or try to build a use case, then learn the libraries that you need to do that. And then any opportunities in MLS BTech undergrad. So again, Aditya, that depends on the exposure you have and the opportunities you get. But I mean, I would say, yeah, as a core applied engineer or applied scientist positions, right after undergrad, it's a little difficult. You need to gain some experience or potentially do some postgrad degrees. It's all difficult based on application because I'm dealing with. Yeah, so Raj Kumar, you can start with medical images. You can see what other people have built, what tech tools they have used, what libraries they have used. Understand those libraries, get an intuition, and then start building your own thing. So that's what I would suggest. Yeah, there's no right or wrong answer over there, but yeah, that's the way to go about it. So yeah, looks like that should be the end of this session. Yeah, looks like all the questions are done. Yeah. Okay, yeah. I see Rajesh Kumar. But yeah, the roadmap still stands. You can still do the same thing, right? Start with some Python. You definitely can. I mean, I think once you brush up your programming skills and get some intuition about these machine learning models, you'll be able to. Yeah. Yeah. Thanks, sir. So Abdul, yeah, I mean, for any direct, you can just contact me later on for any personalized opinion on personalized, suggestions. Yeah. Okay. Yeah. Thanks all. It's been great. Thank you for being an amazing audience. It was fun. Yeah. All right. So thanks all. Uh,
Thank you very much.
yeah.
Okay, thank you so
Yeah.
much.
Thanks,
Thank you
Sunaina.
so much.
Thank you.